I've called this work. This is Carlton Hunt. I've called this workshop together to get some input to the folks that are working on the Bridgewater's new fire station. And basically, there's no public comment as a workshop. We're just going to convey a few thoughts that we provided in writing, and we'll go from there. Brian, what do you have in mind?
Well, Carlton, we're here really to hear what your interest is in the project. We understand the building codes, energy codes that are in effect for the project. We also understand the stretch code, which is in effect for the project. Those are setting some baseline energy requirements. We were not familiar with the specialized code that you forwarded us that we've looked at. We understand that the town has to enact that, and it's not something they've done to date, but it's something we can talk about and discuss as to how that impacts the project. Right now, we are in a phase of the project which is still early in design. It's called design development. So we need to develop all of these strategies into the building. So it's a good time to talk about this. For
Right.
us, it's the right time to talk about it. So the strategies that we have implemented so far are code strategies and code compliance, but we have a very energy efficient envelope. We are making all the requirements that the code requires for air infiltration and for air and moisture transmission. So we're making a tight building. And I know that BER is looking at efficiencies in all of their systems also. With a fire station, we have some, you could say unique requirements. And some of the unique requirements are still, according to our engineers, it still makes sense to use some fossil fuels in this building. And for instance, a way to heat the apparatus bay is a big volume of space. So we don't need the same temperature controls in an apparatus bay than we need in the occupied areas, the office space, the working side of the fire station. Because every time you open up an apparatus bay door, I mean, that's the most inefficient thing you can do, especially in the wintertime. You're heating a space and then the doors fly open and you're back to being extremely inefficient because you need to get the vehicles out. So in that instance, we're looking to employ a radiant slab heat to provide heat. We're not providing any air conditioning for the apparatus bays, but we're just heating it and ventilating it. And the radiant slab brings the heat to the floor surface instead of unit heaters, which are elevated and really tend to heat the upper portions of the space. And it takes a while for that heat to then migrate down to the floor. But that radiant system utilizes a gas-fired heating to get that.
Just give me a second. Does that mean it's got like circulating water within it? That's why you have to heat it that way?
Yeah, it's a liquid that goes through the tubes. And the liquid is not just a water, but it's like an antifreeze.
Okay.
So it can take temperatures and it goes through a boiler. And then the heated liquid goes back through the tubes. And that heat then gets transferred to the concrete slab and then radiates out of the concrete slab, providing heat for the space.
So
if you're walking the floor surface, you're going to feel the heat at that surface. And also it mitigates and assists with any water that's on the floor. And that water would quickly evaporate. So you don't have wet conditions on the apparatus bay floor for long durations of time. or suspended unit heaters probably would take more energy to get that water evaporated to get that level of heat at the apparatus bay floor. So yeah, we're using some fossil fuels in some areas still. We're not 100% free of fossil fuels.
I like that concept, but I would also think about geothermal heat pumps that could put the heat in there and use the Earth's heat down below to do that, and then couple that with some alternative energy. I think that may be unique, but yeah, I would have to look at how quickly it has to recover its heat, that kind of thing. But I would start to look at, and there are some really incredibly, I'm naive on this a little bit, but my understanding is there's some incredibly effective ground geothermal heat pumps that can operate, and air-based heat pumps can operate below zero temperature. So that might be, so I don't know if the expense would be worth it, but I think it's worth from an energy perspective. I'm going to catch Connor in a second there. I think you were waving. The main thing I think the Energy Committee is really, really interested in is ensuring that we have the most energy effective building that we can possibly achieve. A case in point is there is a development here in town. It's called the McElwain School. They put a new building up, and they followed a international code for energy efficiency. In other words, instead of just isolating or wrapping the upper stories above ground, they actually wrapped this insulating material underneath the concrete. So that's the kind of thing, and that's called, I think that comes from the PFIUS, the PFAS requirements, and it's not required, but they built the building. It's an apartment building that HERS rating is 22. I think it's pretty good. So that's our thinking, is maximize that kind of energy efficiency. So what are the other things that I understand the big bays, and I'm assuming you're going to have a bay that's going to take a ladder truck like the big one we have. There's some other options around that. I'm hoping that maybe some of the developments in town, on that side of town, would actually help pay for that apparatus, since there's a lot of large apartments out there.
Yeah, and that's really driving the need. They have a ladder truck now. They're gonna maintain it, but yeah, it's gonna be at this location. And the location on the west side of town was really preferred, because a lot of those new apartment buildings that are going up are on the west side of town. And they're concerned about the way they're building those. It's a lot of wood construction, building those multi-family housing units. And the fire department's really concerned about the level of combustibles in that new construction. That they had no fire service on the west side of town to even respond to those. So yeah, this is going to give them the apparatus they need in a better location in the town to service the development on the west side. It's not that you don't need high apparatus in other parts. I know you're going to need it for Bridgewater State too.
That's true.
And we also seems to be
I'm sorry,
a good alternative for that between Bridgewater and the western side.
there are some new apartment complexes that are proposed right now, and some major redevelopment in the downtown area. That I remember the conversations about having a third station, but the reality is we're going to need a ladder truck on the east side of the railroad track regardless. So that's not your job, but it's basically an issue we need to face here in town. So energy wise, I'm trying to find my notes. Yeah, the PFAS standards, that kind of thing, the specialized code. You know, I know it's may or may not be adopted, but again, that's the driving force for us, is to maximize the energy. The stretch code, as I noted, was updated this year for the state. Bridgewater is a green community, and that carries some interesting thoughts that I'll speak to in a moment. But as a green, if you're not familiar with Massachusetts green community, they provide funding through competitive grant applications, 2 levels. You can do energy efficiency pieces, or they have a new piece that they just put in, and Bridgewater would be eligible for that. It's called basically a zero carbon grant, and you can get up to $500,000 for new builds and restoration buildings that could go to energy conservation. And that's something I've already socialized with the town manager and the town council a little bit. But I think we need to be thinking about that kind of concept here also.
Carl, and what's the procedure for those grants? Could we build the building and then go for the grants, or do we have to go for the grants and then build the building?
I think we have to get I think we should be, I think, as you said earlier, this is the right time to go put the engineering together and then apply for the grant. The green community has two application periods. One just passed and another one comes in October. And that's when I think, I actually think we should be going after that 500,000 for this building. There's another building in town, I'd like to use it, but it's way behind in its development versus this one. So I think the idea would be to have the energy efficiency designs far enough along that we could then put enough specifications in there to say that this is what we would do with the $500,000 toward this building.
Do you know, and can you describe the solar that could be potential in this green community grant? Does it buy the solar panels? Is that what it does?
It could, I think it would purchase anything that gets, I'm going to try to find the right name for that.
Because we've made accommodations on the roof for the support of solar panels. So it's solar ready. But
Okay,
if a grant could then buy the panels and install them, then that wouldn't be a project related cost. It would be a grant cost.
that would be a grant cost. And I would suggest that we connect with Lisa Sullivan. She is the Green Communities Coordinator for the Southeast region and she used to work in Bridgewater. She's actually worked with OCPC for a while. She's got some planning experience, but she's a coordinator and she would be the one that we would really talk about what level of detail we would need for the decarbonization grant. And I included her email in the piece I sent out. But so it probably would cover solar. It might cover insulation type things, you know, anything to get to a decarbonization status. And you can go online, Massachusetts Green Communities. Let's see. There's other things that I included in the traditional energy savings piece, you know, high efficiency water heaters, ventilation, air conditioning, HVAC equipment, basically building controls, technologies that reduce fuel use. We're talking about that with the slab heating, vehicle fuel use. I'd like to see electrification of certain apparatus, but that's going to be a challenge down the road. Any kind of resiliency projects, any kind of renewable energy becomes eligible for the smaller grants. Even if we didn't go for the 500, there's solar thermal serving facilities. There's air and ground mounted source cold climate heat pumps. So that's another piece that we could incorporate. And then there's basic different kind of mixers, etc. What I think, I'm going to throw this out there and you guys can toss it around a bit. I've mentioned before that there is an engineer here in town that's developed a system that's called the ORB. It's ARC Industries. You can go on the website. You have to hunt around a little bit, but he's got a wind turbine that's not a horizontal axis, but a vertical axis windmill that's bird friendly. It weighs 570 pounds. It's about 7 feet in diameter, about 7.5 feet tall. generates 3 keV. And basically it operates with wind at 5 miles an hour and up all the way up to Hurricane 1. So you've got an energy generator that could feed batteries or whatever we need to have out there. Again, that's another potential source for the ground, the flooring. But we recommend you also take a look at that and see if it's something we should look at for energy efficiency out there. It could go on a flat roof, it can go on a slope roof, he can put it on a tower. But he does have one installed at it's up in Burlington, I think at Burlington, Vermont Airport, that they're running a 1-year study that he got funded to put this in. So I keep looking for the data from him, and I still haven't gotten it. But that's just another source of energy.
Yeah, I'm a little concerned that we have a wooded site. I mean, an airport is nice and open but for the wind to generate this, I would think we'd have to be above the tree line to
You
take
may
advantage.
have to be. It depends on how much we have to take down on that north side.
Yeah.
So, again, he can speak to that more. He can put it on a pole. We were going to do that at the golf course, and the idea was put a pole 50 feet in the air and generate it. So there's options, and I know all engineers can really do some neat design work. I'm rambling a little bit here, but if we talk about energy source, solarizing the building, it's wonderful. If we can do the wind, then we can have something that operates at night. The question becomes, how much is it net metering? Is it behind the meter? Is it going to battery packs for emergency outages, that kind of thing? I know that the fire chief here is quite concerned about lithium batteries and the potential for fire and that kind of thing. Legitimate concerns. You can put them outside. You've got enough space there that you could put a battery pack and maybe even something on that. Did you have a design for a small tool, not a small shed or something?
Yeah, there was an outbuilding. There's an outbuilding, yes.
So you got several opportunities there to think about from our perspective. So again, I'm rambling a little wee bit, but sources, and then the other side is energy conservation, maximizing that based on the various codes that are out there. And look, like I said, this one building in town, they didn't have to go there, but they really cut their energy cost, and they solarized that building also. So, and it's downtown, it's on Main Street. If you wanted, I can set up a tour if you wanted to look at it. But
Well, I've got Rich and Tom who are also on the call, and they're representing Building Engineering Resources. They've also been hearing what you've been saying. I'd like to give them an opportunity just to introduce themselves and maybe to give you their insight on what's being planned or what's in the design.
sure.
Thanks, Brian. Hi, everyone. This is Rich. I am, as I think Brian, I got in, sorry for a couple minutes late, but I had to update my Zoom. Zoom had 4 updates that I had to get before it would let me join the call. So
Never happens to any of us.
and we also just transferred to everything's going to the cloud. So that's added just one little more task to getting on here. We typically use Teams. So again, I apologize for being a couple minutes late, but anyway, as Brian indicated, I'm the project manager, and Tom Wiltshire is also on this. He is our HVAC engineer for the project. I myself am an electrical engineer. So I can handle that and typically know enough about HVAC and plumbing just to get myself into trouble. So as Brian pointed, we're right up in Easton. We're in Northeastern actually. So we do a bunch of work down at the university. We've done, and I hate to say it, but we did do one of the multifamily wood construction buildings that's in your town, and they go up for, they definitely are wood frame construction, and all multifamily. It's not just Bridgewater, it's every place. It's all wood frame construction. So
I remember looking at that building, the first one up, and said, why are they making a 5-story building out of wood? I didn't get it. Anyway.
Alton, I think it comes back to because they can.
yeah,
Bobby
very
cheaper.
good.
Bobby
Yep.
cheaper. Anyway. moving on.
Anyway, so we are working our way through the codes. This is quite a code change that has been with the Mass State Building Code in January 1st, and now with the energy and the stretch code coming in on July 1st. So there is a lot that's going on. There's a lot of moving parts. We understand by all means, Carlton, what you're talking about, and everybody is looking for this energy conservation because it has to happen. I mean, there's just no way around it. It's we do, and again, being an electrical engineer, I'm a bit biased, but we are a little concerned about the electrical production and the availability of electricity if everyone in the Commonwealth is going to have an all-electric building. But you know, it's we have to comply with the codes, so we'll leave that up to people smarter than us as to how they're going to get the power from point A to point B. We have like I said, from an electrical standpoint on these codes, there is a lot that goes into the lighting aspect. There's a tremendous amount of lighting control that is now required. There is also receptacle control within the building, so they have to turn off in a prescribed time frame, which and they can't be the receptacles that are on the wall that nobody has anything plugged into. It has to be the receptacles that people are using. When this first came out, that's what everybody was doing. In an office, you'll have a couple receptacles on a wall opposite the desk, and we were turning off those receptacles, and because nobody had anything plugged into them other than maybe a dehumidifier or something. But now the codes have caught up, and we have to start 50% of the receptacles have to be turned off. I think it's after 20 minutes or a certain dwell time. So that can present some issues with everybody working and getting up to go to the bathroom or getting up to go to a meeting or getting, there are some issues there, but we are working our way through it, and we'll do what we have to because it's the code. There are a couple of instances where exceptions to the code that do allow you to not turn off the receptacles. Life safety is one of them for the building occupants, and also in this matter for the building, for what it's serving, the people it's serving. I mean, obviously we can't push that all the way through to the chief's office receptacles, but dispatch area and other areas that it's important that the receptacles stay on 24/7 would be allowed under that exception. EV chargers, quantity of EV chargers is a special requirement from the Mass Stretch Code, and it's our understanding right now that you're at 20% because we're a building use group, and we have to have 20% of the public and staff parking areas have to be supported by EV ready. And again, previous codes, EV ready was we had to have breaker space in the panel boards, and we had to say, yep, we're EV ready. That has changed or will be changing on July 1st, and you're going to need to have the wires run from the panel boards out to the parking lot and be within 6 feet of wherever your chargers that you're going to be plugging into. So that's going to involve obviously work between Brian and the civil engineer to get that worked out. Those are kind of the bigger electrical items. As I mentioned, Tom is on here. He's our HVAC engineer. Just as an aside, we have just finished one project over in Hingham. They got their permit before this July 1st date, but they were looking to try to comply. They had an energy committee also similar to yours, Carlton, and they were almost the same statements were made by them, and because it's being made by everybody in terms of the energy conservation and maximizing the energy conservation and looking for alternate sources of energy. There's no wind turbines over there, but they similar to what Brian said we have for our building, they have made the provisions roof ready for the quantity of solar panels to be mounted on the roof, and we've set it up electrically so it can absorb this all of the solar panels that are intended to go on there. Sure, go ahead.
Yeah, what's the height of the building right now? What is it gonna be 30 feet, 20 feet? Because I'm thinking about you're 85 foot above elevation at ground level, and then you go up 30 feet, and then above that, you don't have that much further to get into the wind zone.
Mhm. Yeah, I don't have the exact height of the ridge, but it's probably at least 30 plus feet up.
Yeah.
The other
So
thing
we should-
electrically, Rich, is we're 100% emergency backup generator. So
Yes.
from an energy standpoint, if there was a need to go to generator power, we have that ability to shed load or to shed and go to emergency generator.
That, yes, it would be available. It would, we're into the fuel source as to what
Right.
the fuel source of the generator would be. The way the National Electric Code reads is that you need to have a reliable supply of on-site fuel. And we have always interpreted that to mean diesel fuel when you're dealing with emergency loads, lighting and whatever else is deemed emergency loads. So we've always looked at diesel as being the fuel source for this generator. We have, with some success, done the natural gas generators, even though they're supplying emergency power to certain loads. But at this stage of the game right now, we would be planning on a diesel fueled generator.
I understand that. You got to have emergency backup.
Yeah.
Just I'm going to cycle back for a second.
Sure.
Are you still planning to put the training tower up that you talked about in your? So
That's even going to go higher. Yeah.
I was going to think that could hire, and this wind thing I'm thinking about could be light enough to go on top of something like that. But just a thought.
Mhm.
Electrical energy wise, the EV chargers, since we have to have a public use for that in the park area, the little, I forget what you're going to call it, but will that be 480 volt quick charge, or will it be 220?
It would be 208. Level 2 is what it would be, a level 2 charger.
So
Go ahead. Sorry.
you can get some fairly rapid charging then.
Yeah.
That's my biggest concern.
Yeah. It's not a level 1, like you have at your house and it takes 8 hours to charge the battery. It's the level 2, which, obviously is not as good as level 3, but it's level 3 is a whole different game.
Why wouldn't you go to a level 3? Because hopefully we'll have people going out there to walk and that kind of thing. Is it a cost issue?
Well, for one thing, right now we don't have 480 coming in. We don't have 480 volts coming into the building. That would probably be the biggest item, because it gets into transformation and finding spaces for transformers and what have you.
Okay.
So that is probably the biggest item, is that we don't have that utilization voltage available to us.
Makes sense to me. Thanks.
Okay, sure. I'm just trying to think here, and I don't want to what else that jumps out at us from a with the latest stretch code and what we're looking at. I think that again, the biggest items is the lighting, the EV chargers, receptacle, plug load control. And I pretty much think that covers it. What I'm going to do is let Tom talk about what our standard HVAC design is. Now it's probably going to have to be massaged here because of the new code that takes effect, but it's already a very energy efficient system that we've been using. And before I get myself into trouble saying something that I shouldn't be saying, we're going to let Tom talk here. So,
hi everyone, Tom Wilshire. Can you hear me right?
Yes.
Yep.
Yes, Tom.
Just making sure because I was having a little trouble with my microphone here. I had to switch to my cell phone. So with the new stretch code, I've been going through it, and it doesn't look like we're going to be able to have gas boilers to heat spaces. So we're going to have to rethink how we're going to do the apparatus bays radiant. I'm not sure exactly how we're going to do that yet, but I will figure it out. I mean, the office building, that's the easier part. We use the VRF systems. They're very high efficient systems. You know, each space will have its own dedicated heating and cooling abilities. VRF heat pumps are, you know, very, very efficient, and they can actually steal heat from one space and put it to a different space, or if another space needs cooling, you know, it can steal cooling from another space and bring it to that space. So there are times where the compressors aren't even running and you're still heating and cooling spaces properly. They're very nice systems.
So it's a little bit like my heat pump hot water heater.
Yeah, exactly. It's a heat pump system, and it's called VRF because it's variable refrigerant flow, because the refrigerant flow varies from where cooling is needed and where heat is needed, and it transfers that energy all by itself.
Great.
It's a very nice system. We use it all the time with great success. The apparatus bay, typically we would use gas-fired boilers to feed the radiant system, because we would have a radiant system for heating, basic heating of the garage, and it evaporates the water off the truck. So it's a very nice system. It works really, really well. And we would also have unit heaters up high for fast recovery when the garage doors open. You know, we don't want sprinkler freezing. We need to recover that heat pretty quickly. So we would have some unit heaters of some type, either electric or hot water, hung in the bays to recover that that heat when, you know, it's 0 degrees outside and the garage doors are open up, because that heat is just going to go right out of the space. You know, again, with the new stretch code, it doesn't allow gas heating of spaces, is how it's worded. So I am going to have to think of something else. I know we do have heat pumps available that can produce hot water. The problem with those is they take up more space than I would like, and I'm sure Brian would like.
Yeah.
So it's something that it's something that needs to be coordinated and really thought through.
But so the oil fired heat that gas you've been using, that's radiant heaters though, right?
Well, no, so the radiant system we're talking about, the boilers, it would be a gas fired boiler that produces hot water, you know, similar that you'd have in your house for fin tube radiation. And we would have the radiant system would be in the slab of the apparatus bay, in the concrete slab itself. We would have tubing that would run, you know, zigzag through, and it would actually heat the entire concrete slab. That way, when the trucks pull in all snowy and wet and everything, that water would fall on the floor and just evaporate relatively quickly with the radiant floor system. And the radiant floor system keeps the bay at a nice temperature, and it keeps the floor nice and warm. You know, people are happy when their feet are warm. So,
Well, you got a lot of heat momentum in that concrete too.
Right.
Once you warm it up, it's gonna stay warm.
Exactly. It has a
Right,
nice
a thermal mass.
Yep.
It creates a thermal mass. And the other thing the town wants to invest in, which would help the energy loss, is they have rapid opening doors now on the apparatus side. So on the frontline vehicles, the ones that are always leaving at a call, they would have doors that would open within seconds, instead of the traditional sectional doors that roll up. And they take a long time to roll up and then clear the space. And then the vehicle leaves, and then it takes time for that door to come back down again. These are side folding bifold doors
Okay,
that they can rapidly open, and then the vehicle can exit, and then it can rapidly close. So you're trying to contain the energy that's in the space instead of allowing that sectional door to lose all the energy.
I was thinking a barn door, but I like the bifold better.
Well, they help on the energy conservation, but they are expensive, and they've elected to put them, because of the cost, they're gonna put them on the front of the front of the apparatus space and not the rear. Because
Where
the
they come
rear
out.
doors don't typically need to open. You're only gonna have one vehicle that's a drive-through vehicle. The rest of them are gonna be drive-in, drive-out, back-in vehicles. And ambulance, such as ambulances, they'll just back into the bay.
So you basically have a rapid response section that lets people get out of there as fast as they can.
Right. They'll get out as fast as they can, but we'll try to contain the energy as the best we can.
Yeah.
Yeah,
All this stuff sounds good. I like what I'm hearing. You know, whatever we can innovate or I guess it's what's available. We don't have to invent something, but you know, maximize any of these kinds of concepts would be fantastic. I'd like to see a model that it's become the model of fire stations, quite frankly.
Also, Carlton, we typically use air source heat pumps. That's what we specify. The ground source heat pumps, I know you mentioned that before. We don't design the ground source wells. They would have to be designed by someone else, and the ground would need to be tested if it's even a feasible option. And that would also be done by someone else.
My neighbors had a ground source heat pump for 30 years. So,
Yeah, I mean, they're good systems. They're wonderful. The problem is, you know, especially a lot of the buildings that we do, you know, they're on finite lots, you know, really small lots, and it just doesn't make any sense. I know we have a much larger lot here, but you know, I just want to make sure you're aware the ground would still need to be tested. And, you know, another engineer would have to figure out, you know, how many wells we would need and if they would fit on the available land.
well, I'm going to encourage, I don't want to run the price up, but I also think longer term price, energy savings, we have to look at all these options. Thank you.
So I think that's pretty much it for the HVAC system. Do you have any questions?
I'm somewhat ignorant, enough to be dangerous when I ask questions. So I appreciate the candor you're showing, but again, bottom line is efficiency, and you have to do the cost trade-off, of course, short and long term.
Carlton, what's your position on other gas-fired appliances? Like there's a commercial kitchen in that we're designing. And I think the fire department's preference would be a range in there. And if that's what they're requesting, we'll say, sure, that's what you're requesting. Is there a position of the energy committee that you would come out and not encourage that? Or would you feel that appliance was something that we could utilize within the kitchen just for their purposes?
You know, this is one of those places that I know enough to be dangerous.
I just asked the question. I don't have the answer, but
I understand that efficiency of gas and that kind of stuff and the heating, but I also read enough now to know that there are concerns. Again, maybe they're not all in the kitchen all of the time, so the exposure to some of these supposed things are not as great. So the Energy Committee has not taken a position. I think we have to, I would like to see minimizing fossil fuels everywhere we can. That would be my position. So electric, if we can figure out a better electrical system, I don't know.
Well, electric could be utilized for the ovens and the baking. I still think they were expressing a desire for gas on the cooktop, but
Well, they also, I know they cook out, you're gonna make a gas-fired grill outside too? I
well,
know they
that,
cook outside a lot.
yeah, they do. They do. And whether that's just their own appliance or whether we feed that with gas, it hasn't been determined.
Well, there is one down at the station downtown that is right in Music Alley, and it's a big grill, so I think it may be fed from the gas.
You know,
that
if
comes
it's.
out of the building.
you-
And it's a
you
big
probably
100-pound
should-
tank on that grill.
Oh, it's a 100-pound tank? Yeah.
It is.
So everything I've heard sounds great. You guys are the experts. I don't want to belabor it too much. I think the main thing that we know about is what I wanted to convey. I think evaluating the best grant approach, the town needs to talk to you guys a bit more about whether this green community, which is the right thing to go after, the smaller grants that you can go after every year, or the larger grant, the 500,000. Once you do that, you can't apply for more grants for 2 years. So the town has to kind of balance those things off. But I can see the fire station being the immediate need. So I'd probably push that if I were asked directly. We talked about alternative inner sources, all of them small and large. In the stretch codes we talked about, the wind we talked about, the energy storage on site. That's a question. How much we have diesel generator backup, but are there other alternatives for providing power, at least a minimum power for the housing and the offices and that kind of thing? How much backup do we need for that? 24/7 for the radios, all that kind of thing. But
We're only providing a UPS system for that short delay between power outage and generator power initiation. So yeah, we have batteries on design for the building, but it's not for any long-term use. It's more of that short-term lag between the power outage and the generator.
But yeah, and you guys know the safety issues around that from all aspects, you know, the lag time and that kind of thing. So you have to minimize that. So I understand that. Beyond that, I don't know that I have any other questions, et cetera. I just well, the other one was I think you've got grant money or money was given by the Toole family that for the park in that park. I think the electric charging stations will be important there to engage those at that location, and that wiring of that is going to be important. But beyond that, I don't have personally, I don't have any more questions. I do see one town councilor on here, Brad McKenna is there. So I don't know if you want to open up to any other questions from people or just leave it at this.
We're here. It's your meeting, so we're here if there's any questions.
Is there anything that we need to engage more with, more in-depth research or anything, or is this level about what you expect and maybe from us?
I think it's what was anticipated, and I think we just have to convey some of these back to the town, and because some of these would include additional testing or additional engineering, and we might need to justify the costs. to say if we're gonna go to geothermal. It's just not a decision to say we're gonna do it. It's a decision to say, are we gonna investigate it further? And once we investigate it further, we'll have a better idea on what the overall cost would be, but there's still a cost to investigate further. And there's borings that'll have to be done and some engineering evaluation that'll have to be done. So it's a conversation that's ongoing, the way I see it.
I just don't know how the proximity to the wetlands out to the north there. I don't know if that is a factor. Maybe there's someone else who can talk about having more wetlands and heat storage down in the earth, that kind of thing.
Well,
Maybe
we're-
there's some paper studies.
We're surrounded by wetlands on this site, so I don't think we can be doing any disturbance within the wetlands, which limits
No.
the amount of available land we have to, as Tom was pointing out. If we need multiple wells, we need distance between the wells, so do we have even the site area? As far as soil compositions, it's better if we're in rock than if we're in sand. Obviously, we're looking for a thermal mass. So
Mhm.
once we take the borings and do borings, we'll get them analyzed, and if it's a sandy soil, and if it's a wet sandy soil, then that's not good news.
Right.
If we find bedrock and continue to core through bedrock, then that's a better answer. So that investigation would help answer the question of how much is this gonna take?
So how far down do your borings have to go for the foundation, that kind of thing?
For investigative purposes, we just need to
Yeah.
find out, we just need to core into the rock and assume that it's, consistent.
Are you looking at 20 feet, 10 feet, 50 feet?
Well, the well themselves would be about 250 feet or to get a well installed. They go down about 250 feet. But
Okay,
the
that's-
to investigate them, I don't know if you have to go down that far.
Well, I'm just thinking, I think my neighbor who has it, I don't think he's down, he may be down 200 feet, I'm not sure.
Yeah.
But that would be a big issue, yeah.
Yeah.
But anyway, it's worth, maybe there's some paper studies that can be done a little bit to figure out what this is in this area. It's pretty cobbly, at least where I live. I think we could probably say we've exchanged the ideas that our committees talked about. You guys know the details much more. We are certainly here to listen. If you want to feed something to us and get a response, I'd be more than happy to do that also.
Sounds like a good,
It's the engineering part that, even though I've got advanced degrees, I'm not an engineer. I was an engineer wannabe at one time, but I guess if there's no other questions or other comments, I'm gonna call it a day, okay?
thank you, Carl.
Thank
Let
you.
us know what we can do.
Okay,
Thank you, gentlemen.
thank you.
Thank you.
Have a good night.
You too. Bye-bye.